Hi everyone. Today we're going to start a unit on trig, and basically it's going to cover our next three chapters. Chapter 9 and 10, we're going to go over some things you have learned before. We're going to add to it and kind of get the basics of trigonometry down. And then in 11, we'll get to the calculus part where we'll learn how to do limits and derivatives of our trig function. That's a little while from now though. So what I want to start with for chapter 9, before we get into any trig, let's just start with angles, because you have to really be comfortable with angles before you can do any trig at all. So we're going to do a unit on just the difference between radians and degrees and basically how to measure angles. So let's start with some of the basics. Usually in a textbook, if the author is talking about angles, he uses Greek letters, and that could be alpha or beta or theta, maybe gamma, there's some others. These are the three main ones. It doesn't have to be. You can have a question that says the angle is X or Y or Z, but it's kind of a notation to let you know that, yeah, this is what we're doing. We're talking about angles if you see a theta in there. The next thing I want you guys to know is that angles have an initial side and a terminal side. An initial means starting or beginning, and terminal means ending. So one of the things that's different about trig from the first time you guys learned angles, you would have learned it in a geometry class, or probably what we called Math 4 here at Western. Basically, like if I drew an angle like this and said this is a 40-degree angle, that's just a 40-degree angle. But if you have an initial side or a terminal side, then what could be happening is the angle could be going from here to here, or it could be starting here and ending there. And depending on which one you're using, one of those is going to be 40 and one of them is going to be negative 40. And that's the difference. Now we are going to use something called standard position for our angles. Standard position is when the initial side points directly to the right, a perfectly horizontal line pointing to the right, and then we measure counterclockwise from there. And there's a picture of it right there on the screen. The initial side is the bottom side, it's perfectly flat and pointing to the right, and then the angle is measuring counterclockwise from there and ending at the terminal side. So our direction of our angle is basically going this way. And I said on this is exactly how we measure in the unit circle. And we're going to do unit circle again soon. I know you guys have done it before. You probably remember some of it from last year. But this is exactly how angles are measured in the unit circle. Now when it gets to the actual units of measure, there's two ways to do it. Let's start with degrees. You're probably more familiar with them because you've been doing them for longer. You probably learned this way back in elementary school. But here are some of the basics of degrees. There are 360 degrees all the way around a circle. So if I start here at 0, let's say we're doing standard position, and I go all the way around a circle and end in the same place, that's 360 degrees. A right angle is 90. That's another real obvious one you guys learned a long time ago. It's an important one though. And then we also have something for partial degrees. So this is something I want to mention to you. I don't really emphasize it in this class, but I want you to know it. If you have a partial degree, like let's say we have something more than 22 degrees but less than 23 degrees, you might use a decimal, like maybe you call it 22.4379 degrees or something like that. And that's fine. But there's another way of doing it. You can use what's called degrees, minutes, and seconds. And it basically just shows partial degrees. The way it works just like time. There are 60 minutes in one full degree and 60 seconds in 1 minute. So it basically, like, the degrees are like an hour, and you have 60 minutes and 60 seconds per minute. And that's a real accurate way to do partial degrees. So if you ever see a question, like I said, I'm not going to emphasize it, but you might see a homework question here or there in the book where it's talking about an angle and it says, 10 degrees, 15 minutes, and 20 seconds or something. A good way to deal with it is just convert it. And you can very easily convert it by dividing and adding everything up. So you say the degree part is the degree part. I'm going to leave that. The 22 degrees, whatever number you see here is the number you're going to see here. That's the whole degree part. Now the minutes and seconds part, this is your decimal part. Now there are 60 seconds in 1 minute, so I take the minutes part, divide by 60. That converts it to a decimal. There are 60 times 60, or 3,600 seconds in 1 full degree. So I take the second part and I divide that by 3,600, add it all up, and it'll convert it into this decimal part over here. So it's just something I want you to be aware of. I don't emphasize it, I don't put it on quizzes or tests, but I do want you to be aware of it because you'll probably see it on a couple homework questions scattered in. All right, so what I really want to focus on today is radians, because radians are the ones you've learned more recently. You've had less work with, less time to work with them, and also they're a little bit harder for some people just because they involve fractions. So let's start with the basics. This is the definition of a radian. A radian, one single radian, is an angle that intersects an arc or a piece of a circle whose length is the same as the radius. So you can see where the name comes from. Radian, radius, they're very closely related. So what this concept is saying is, if I have a circle with a radius, let's say the radius of the circle is 10, just to throw a number in there. 10, whatever we're measuring in, centimeters. So if I measure out 1 radian, then what I'm saying is from here to here, this piece of the circle, I'll highlight it in purple right here. Imagine the circle was made out of wire, and I clipped the wire at those two ends and I straightened it out. That purple piece would be exactly 10 centimeters long also. That's what 1 radian is. It's saying if I make an angle where the piece of the circle that's contained or intersected by that angle is the same length as the radius, that's what we call 1 radian. Now, these are used much more often than degrees. Once you get to more advanced levels of math, people stop talking about degrees and start talking about radians. In fact, one of the things for the AP test for next year, AP Calculus, only radians. That's written into the directions. There are no degree questions at all on that test. The whole test is in radians. There's also no symbol for radians. Degrees have a symbol. Like if I was talking about 30 degrees, I might write something like this, 30 and then with the degree symbol. But if I was talking about pi over 6 radians, I would just write pi over 6. There is no symbol. There's no R for radians or anything like that. If anything, if you really wanted to be specific, you could actually just write the word radians, pi over 6 radians. But it doesn't have a symbol. And then the last thing here is, just like we talked about with degrees, we said 1 full circle is 360. A full circle for radians is 2 pi. 2 pi radians. And actually, while I have this picture on the board, it's a good way to kind of understand where that comes from. If you think about the circumference of a circle, one of the equations we know for a circle is the circumference is 2 pi r. So think of it like this. Think of it as 2 pi times r. Well, remember, when I did my radian picture, this 10 right here, this is r, this is the radius. So what you're saying with this formula, if I'm doing the circumference around a circle, it's going to take 2 pi of those, whatever it is, 2 pi r's to get around the circle. Well, if it takes 2 pi of those to get around the circle, then angle-wise, it takes 2 pi of these to get around the circle. And that's kind of where that number comes from. It comes directly from the circumference of a circle and the relationship between a radius and a radian. But what you really want to remember is that 2 pi radians gets you all the way around a circle and back to where you started. Now, because a full rotation is 2 pi, we talk about radians in terms of pi. And this is why some people think they're harder than degrees. Degrees are mostly whole numbers, 20 degrees, 30 degrees, 90 degrees, 45 degrees, whereas radians tend to be fractions. You have things like pi over 2, 5 pi over 6, 7 pi over 4, things like that. Those are all common unit circle angles, which we'll go over when we do the unit circle. But for now, I just want to kind of understand what a radian angle is. So let's take that last one, 5 pi over 6. Let's say I asked you guys to just sketch or just know like what that angle is. The way you want to do it is focus on the fraction part. When you see 5 pi over 6, you can think of it as 5/6 pi. That's really what it is. The number part, the fraction part here, tells you how much of one single pi you are doing. So you're doing 5/6 of pi, and pi is half a circle, or basically a straight line is another good way of thinking about it. So if you took the top half of a circle, or a perfectly straight line, you split it up into 6 pieces, and then you counted off 5 of those pieces, that would be 5/6 of 1 pi, or 5 pi over 6. So this is what it would look like. I'm going to start with a circle, because we're kind of working towards the unit circle. I want you to get used to that picture. And what I did is I took the top of the circle, and I did the same thing on the bottom actually. I took the top and bottom circle, and I cut it into 6 equal pieces. So starting on the top, and we'll do standard position. So I'm going to say this is 0. This is where we're starting directly to the right. If I go counterclockwise, this is 1, 2, 3, 4, 5, 6 pieces, and then you're at pi. So each one of those is 1/6 of pi, or pi over 6. So if I count 5 of those, that's 5 pi over 6. It would look like this. Starting at 0, this angle right here, from red line to red line, is 5 pi over 6. And I did that visually by taking half a circle, breaking it up into 6 pieces, and counting 5 of them. All right, so for our examples today, let's do 2 sketches. One kind of just like the one we just did with radians, and then another one in degrees just to show the difference. So if I wanted to sketch 11 pi over 8 radians, let me start with my straight line here. And I'm going to split it into eighths, because that's what we want to do. You know, you're always looking at the denominator and splitting it into that many pieces. So I would do this. I would probably start by splitting the top in half, split each half in half, that gives you fourths, and then split each one in half again, that's going to give you eighths. So that's a good way to count 1, 2, 3, 4, 5, 6, 7, 8. That's pi over 8 that I just drew. 1/8 of pi is each one of those. But then I look at the top and I go, well, I need 11 of these, so I need to keep going. I need the bottom too. So let's split the bottom, split that in half, and then split those halves in half. And now I have 9, 10, 11, and I'll stop there, because that's what I needed. It was 11 pi over 8. So 11 pi over 8 starts here at 0, because remember that's standard position. It goes around past the 11th one. This angle right here is 11 pi over 8. And that's how radians work. You have to think in terms of fractions, and you have to think that a straight line, or the top half of a circle, is 1 pi, and then just work with fractions from there. So that right there is a good approximation, a good sketch, the red one, of an 11 pi over 8 radian angle. Okay, below it, let's do degrees. This is actually a little easier and also a little bit less accurate. So if I'm going to draw this angle in degrees, let's start at 0 again, because we're doing everything in standard position right now. What I know about degrees is that this is 90, that's a right angle. This is 180, and that's as far as I need to go. So what I'm going to do for this one, remember I said a minute ago, this is much less accurate. I'm not going to break it into, like technically what I'm doing, I'm breaking the top of the circle into 180 pieces and counting 141 of them. Now we're not going to do that, obviously. I'm not going to break it up into 180 pieces. So we're just going to approximate. I'm going to say, let's see, 141, if I compare it to 100 between 90 and 80, it's a little past halfway. 135 would be halfway. So I'm just going to approximate it. I'm going to say 141 would be maybe right here. Oops, 140. Let's fix that. That would be about 141 degrees. So degrees are easier because they're whole numbers. They're also less accurate. You're just kind of approximating. But this is what we're doing for day one. I really just want you to spend one day understanding the difference between the two angles, degrees and radians, and especially up here, knowing how to visualize radian angles. If I tell you 17 pi over 3 and you just have no idea what that is, you're not ready to start trig yet. You got to know those radian angles before we can get to the sines and the cosines and the tangents. And that's the plan for today.